Welcome to my YouTube channel. My name is Priya Patil and today I am going to cover a topic of engineering mechanics, that is trusses by section method. So without any delay, let's get started. Many times we can see construction like this. So this is nothing but the trusses which can use to support the construction. So in mechanics we can draw the trusses like that to study the forces in members of that trusses. So how we can find the forces in the members of that trusses? So here are some steps to find the force in a given members of trusses. So first step is calculate support reaction by using equilibrium condition, which are summation fx, fy and summation of moment. We can calculate. Cut the trusses by a section line passing through the members in which we want to find the forces. Analyze the section. After drawing section line, analyze right hand side and left hand side part of that section and choose that section which has less number of members and draw a PD of that side of trusses and draw a PD of selected section and apply equilibrium condition to calculate force in a given members. So these are some simple steps to calculate the force in the given members of trusses. So see here question is given. Question: find the forces in members EG, EF and FD. So in which we have to calculate the force in member EG, EF and FD. So it is highlighted by green, in which height of this trusses is given as 2 meter and the distance between the point B to D is 3 meter, D to F is 3 meter, F to H is also 3 meter, in which 20 Newton force acting downward at point F, 10 Newton force is acting downward at point D, and here are two supports are provided, one is hinge support and another is roller support, due to which hinge support horizontal reaction force and vertical reaction force at point B is generated, and at a roller support vertical force RH is developed. So see the solution how we can calculate the forces in members. So see here, it is a given question. First you can draw the given structure of the trusses and mark the members in which you want to calculate the forces. So first step is, by applying equilibrium condition, we calculate summation fx, which is a summation of all the horizontal forces acting in the trusses. So in which we can see here, there is only one horizontal force acting in the trusses. So we can take it as RBH is equal to 0. We can calculate summation Fy, which is vertically acting forces, and the summation of that vertical acting forces, which is as following: RBV which is acting at point B vertically upward, minus 10 which is acting at point D vertically downward, minus 20 which is acting vertically downward at point F, and RH which is acting vertically upward at point H. So by taking summation of this, we can get RBB plus RH is equal to 30, and give it as a equation number 1. So now we can calculate the moment. So we can calculate moment at point B, in which moment is a nothing but force acting perpendicular to its length. So here moment we can take as 10 into 3, in which we are taking moment at point B, so that RBH and RBV are cancelled as they are passing through this same point. So the moment due to point at point D due to 10 Newton is 10 into force into its perpendicular distance, that is 3 meter, and 20 into, that is acting clockwise into its perpendicular distance, is 6 meter, and then RH which is rotating to the respective point anti-clockwise from the distance 9 meter. So we take so we can take summation of the moment of the all points or the forces about that point B. So we can get the equation here. After the calculating, we can get value of RH, which is equal to 16.66 Newton. In the next step, we can put this RH value in equation number 1. So we can get the value of RBV. So see here, we put RH value, that is 16.66. So we can get RBV is equal to 13.34 Newton. So after that, after calculating the support reactions, which are RH, RBV and RBH, we can draw a PD of section plane. So how can we choose section plane? We can choose section plane like that. The section cutting plane passing through these 3 points. So we can see here at the right hand side and the left hand side of the section plane. Right hand side has less number of members, so we can choose the right hand side for a of the section for a FPD. So we can draw here the FPD of section plane of the right hand side, because of it has less number of members at the right side of the section. So see here, we've drawn a FPD of the section plane of the right hand side, in which we can calculate theta by the formula tan theta is equal to opposite upon adjacent, in which we can calculate theta. We can take perpendicular from the point G to the plane FH, from which it is given that height is equal to 2 meter and its total length is 3 meter and half of that is 1.5. So by using this we can calculate tan theta, which is equal to 2 meter divided by 1.5 meter, which is equal to tan theta is equal to 1.33. So to calculate theta, tan inverse 1.33, we can get theta is equal to 53.13. So this theta and this theta are same. By using the adjacent law, and here after calculating theta, apply equilibrium condition and calculate summation Fy, in which all the vertical forces are added, in which the forces acting upward are positive and acting downwards are negative, from which we can calculate FFE. So the force FFE is equal to 4.70 positive, which means it is tension. And the next equilibrium condition is summation of moment at point F. So after the applying summation of moment at point F, we can get Fg value, which is force act in member Fg, that is minus 24.99, which indicates that the force is compression force. So like that we have calculated two forces, one is FFE and Fg. So now we want to calculate FD force. So see here, after summation of moment, summation of vertical forces, we can apply summation of horizontal forces, in which we can calculate or add all horizontal forces acting in a section of a trusses. So like that, the forces which are acting toward right side are positive and which are acting left hand side are taken as negative. By the formula of summation Fx of the equilibrium condition, we can get FFD, which is equal to 22.49 Newton, and it is positive, which indicates that it is a tension in a member of FD. So see here the summary. In a question, they are asked to calculate force in EG, force in EF, force in FD. So we can calculate it as EG is equal to 24.99 as a compression, and EF is equal to 4.70 Newton tension, and FD is equal to 22.49, which is tension. So this is the answer of the given question, in which we can calculate the forces in a given member. So thank you for watching this video.